Hi class, today we are going to be doing 8.5, finishing up the chapter, and we're going to be doing angle of elevation and depression. Our objectives today are going to be to solve problems involving angles of elevation and depression, and then we're going to use those angles of elevation and depression to find the distance between two objects. So one, we're either going to be doing with a lot of word problems today, and so we're going to find distance, we'll find height, and different things. We're going to be, again, using right triangles. Remember, chapter 8 is all about right triangles. So let's first define. The angle of elevation of an object as seen by an observer is the angle between the horizontal line and the line from the object to the observer's eye, which is their line of sight. So if we draw a little picture, first off, there's you, and you have a line of sight, which is horizontal. And let's say that we're looking at the sun. Okay, your line of sight can also go up to that, and that's this angle of elevation that we represent with theta, which is that circle with the line through. So this is angle of elevation. And if we drop down our horizontal or our vertical line, we're going to make a right angle. Then we also have angle of depression. If the object is below the level of the observer, then the angle between the horizontal and the observer's line of sight is called the angle of depression. So this would be like if you are in an airplane, and please excuse my drawings today, we're going to have some lots of drawings that we're going to be doing. So let's say that you're in an airplane, really bad looking airplane, and you are looking down at, let's say we're looking at a tree. Okay, when you're looking down from the horizontal, that is going to be our angle of depression. And if we drop down here, then we have a right triangle. We also can use angle of depression from the ground too. If we look here, remember if we have parallel lines, that this also becomes angle of depression down here. All right, so let's just get right into it. All of these problems are going to be following the directions. Draw a sketch to represent the problem, include the given numbers and a variable to represent the unknown. Show the trigonometric equation needed to solve, and then give the solution. So draw a picture, write a trig function, and solve it. A tree casts a shadow 25 feet long. The angle of elevation from the tip of the shadow to the top of the tree is 64 degrees. Find the height of the tree. So we have a tree, and it casts a shadow that's 25 feet long, and the angle of elevation to the top of the tree is 64 degrees. Find the height of the tree. All right, so if we look here, we are going to notice that we have our opposite and our adjacent. And with opposite and adjacent, we are going to be using tangent. So we have the tangent of 64 equals our opposite over our adjacent. All right, we want h by itself, so we need times by 25 on both sides. So h is going to be 25 times the tangent of 64. So pull our calculators out, and we want to do 25 times the tangent, nope, too far, of 64. All right, and what do we get? We end up with a height of 51.3 if we round to one decimal place, and our label is going to be feet. So all we're doing here is now we're just taking a real world situation and putting it with our trig functions. All right, so a jet takes off and rises at an angle of 19 degrees with the ground until it hits an elevation of 28,000 feet. How much ground distance is covered in miles? All right, so our jet's taking off, and our angle of elevation is 19 degrees. And it's at altitude. Remember, altitude is the height of something, 28,000. And we want to know how far off the ground, or I mean, how far across the ground did it cover? So we end up with our opposite and our adjacent. So there's that tangent again. Tangent of 19 equals our opposite over our adjacent. This time x is in the denominator. Now remember from our 8.4 video, day 2, if x is in the denominator, it's just going to switch spots with our trig function. So tangent of 19. All right, so let's go ahead and take our calculators and take 28,000 and 3 zeros. We're going to divide by the tangent of our 19 degrees. So we end up with 81,317.9 feet. X equals 81,317.9, but this is in feet. Remember that our question asks us in miles. So how do we change feet into miles? We'll go ahead and take our 81,317.9 feet and divide it by the 5,280 feet. That's going to get us our answer in miles. So I want you to do that on your own. All right, so let's go ahead and try some more of these. From the top of a vertical cliff 40 meters high, the angle of depression of an object that is level with the base of the cliff is 34 degrees. How far is the object from the base of the cliff? All right, so our cliff is going to be 40 meters high, and it has an angle of depression, so that means that if we go down, it's got 34 degrees angle of depression. And we want to know how far away is that object from the base of the cliff. Well, remember with our parallel lines that 34, because it's an alternate interior angle, can be switched to down here. We are given our opposite over and our adjacent here. So tangent. Think about this. We've done tangent the last 2 problems and this time. Most of our angles of depression and angles of elevation will be that tangent unless we know this diagonal length here. All right, so we're going to do tangent of 34 equals our opposite over our adjacent. All right, so I set that up for you. You pause the video and you go ahead and do the math for this and come back and see if you got the right answer. Did you end up with 59.3 meters? I sure hope so. All right, the pilot sights the beginning of a runway and must approach it at an angle, 5-degree angle of depression. If the plane is 182 kilometers from the beginning of the runway, which is ground distance, what's the plane's altitude? Remember we talked about altitude is the height. Round to the nearest kilometer. All right, so go ahead and draw our right triangle. Here it says it's an angle of depression, so we're going to put 5 degrees there, and then we're going to drop down 5 degrees here. If the plane is 182 kilometers from the beginning of the runway, then it says, what is its height? All right, so here we have our opposite and our adjacent. So tangent of this, tangent of 5 degrees is equal to our opposite over our adjacent. All right, x is in the numerator, so you're just going to times both sides by 182. Come with that done for tomorrow. All right, ooh, this one's a good problem. The surveyor is 100 miles from a bridge. The angle of elevation to the top of the bridge is 35 degrees. The surveyor's instrument is 1.45 meters above ground. Find the height of the bridge to the nearest tenth. So we have a surveyor's equipment in that little picture there. And this is 1.45 meters off the ground. Now the line of sight to the bridge is going to be from that. Okay? And the angle of elevation to the top of the bridge is 35 degrees. I'm not going to draw you guys a bridge. I've tried in the past. Ooh, really bad results. So we're just going to not draw a bridge. All right, so we have our right angle here. And it says that the surveyor is 100 meters from the ground. We want to know how tall is that bridge. All right, so are we going to use the 1.45 in this problem right now? No. We're going to use the 100 and the x right now. And 100 is our adjacent. And the x is going to be our opposite. So we're going to use tangent of 35 equals our opposite over adjacent. So let's go ahead and crunch those numbers. We end up taking our 100 times our tangent. There we go. Tangent of 35. And we get about 70, we'll say. Okay, so x equals 70.0 because it had a little extra meters high. But the one thing that we need to keep into consideration is that we're taking that from the ground, from the surveyor's instrument, which is 1.45 meters above ground. So if we include that, our height is going to be 71.45 meters. All right, if we round that to one decimal place, that works too. All right, last one. The search and rescue team is airlifting people from the scene of a boating accident when they observe another person in need of help. The angle of depression to this other person is 42 degrees, and the helicopter is 18 feet above the water. What's the horizontal distance from the rescuers to the person to the nearest foot? All right, so this picture is drawn for you. I don't think I'm going to need to do any setup for you. All I want to remind you is round it to the nearest foot when you get to the answer. All right, guys, have a good day.